Good evening, everyone. Time is 7 o'clock in the evening. So let's start the program on time. And thank you so much for joining the session. And we already have with us Dr. Anjali Updhyay, ma'am. So I won't take much time. So this is very limited time, 1 hour, 1.5 an hour session. I request ma'am to kindly please take over and take forward the session, please. Thank you so much.
Thank you, sir. Thank you. So today I'm very happy. I'm audible, sir?
Yes, ma'am.
Okay. So today I'm very happy and delighted that Dr. Pulanath sir has given me this particular opportunity to present myself for the sample size determination. So basically, whenever the research is there, it is a very important task that whenever we set a research design, the samples is necessary. And basically, whoever you are, maybe you are a student, you are a researcher, you are faculty, or any other kind of the research is going on, then the sample is very, very important thing. Everybody knows us that the basic terminologies of the statistics, that what exactly the population or what exactly the sample, how the sample are going to represent the population, and how we are going to generalize this sample on the basis of the statistical two laws, that the law of central limit theorem as well as the law of inertia, that the characters of the sample and characters of the population both are the same. That is why we are using these particular samples for the predictions, for the generalizations, and whole the research design. So basically, getting the sample size, it is to say it is a very simple task, and to say it is a very difficult task also. Because sometimes what happened, students and the researchers, as being a statistician, they directly come to us and they are asking me that this and this is my title and what is my sample size. It is not that easy to say that what exactly the sample size. Or some students of the medical students are directly come to me that this and this is my research design, tell me the sample size about this. Or the some researchers directly, they came with a thesis, dissertations came with us, and they say that this and this sample size is I selected, now you put it in the statistical methods of this. And this is very difficult task in that case. But first of all, when we know the scientific methods of sample size determination and scientific methods of how to calculate the sample size, and because there are so many and different methods are there. Basically, when we know the terminologies of the sample size, at what is a confidence interval, what is a power of test, what is a type 1 error, what is the level of significance, then it is very easy to calculate the sample size. Because so many methods are there, like a table method is there, maybe the computer statistical softwares are available to calculate the sample size. But at least you should know that what exactly the base of the sample size and how the sample size is differ with the effect size or the research design or the sample design or the sampling methods. These are the ways that the sample size differs. That's why today we are learning that what exactly the sample size. So I'm going to share my PPT over here. With me 1 minute. Is it visible to all?
Yes, ma'am.
Yes, ma'am. Yes.
So we'll start with the sample size determination. Okay. In the today's session, we are going to what is exactly the sample size, how we are going through the methodology of the sample size, how large the sample it should be, or how small it should be. Okay. What are the methods to determine it? What are the factors to determine the sample size? And what exactly the methods to calculate the sample size? As well as in this lecture, I am going to take a simple case studies. That is why you can understand how to calculate the sample size for a simple case studies also. So at the end of this presentation, You understand the significance of the sample size, determine the sample size in a very easy methods, okay, and what are understanding the factors of sample size. Now, basically, first of all, we understand that what is a sample? Sample means it is whenever we take a population, take a for simple example of the teacher. And so many types of teacher is available. Maybe those are Anganwadi teachers, those are primary teachers, those are secondary teachers, those are college teachers, those are the deans, those are the principals, those are Kulaguru, all are the teachers. But suppose I want a population, it is a very broader term. But whenever I take a target population of the teachers from the engineering colleges, this is my subpopulation. Again, I categorize it this subpopulation to the very narrow area, that the teachers from the engineering college in the district of Kolhapur. It is again narrowed down. That is why what is our exactly the reference population should be getting through the review of literature, first of all, or the proportion of the population. And after that, whenever I got my target population, then I am thinking about that what is my exactly the sample size. Whenever we are getting the sample size, two basic laws are there. Okay, the first law is that there is a large number of inertia. Large number of inertia means from the population I should get a sample sufficient number of sample size. Whenever the sufficient number of sample size, it may represent the population properly. Simple thing. And the second one is all the characters of the sample and the population, whatever may be the variability is there, whatever may be the standard deviation is there, it should be the representative of the sample. Again, whenever I'm taking the some samples from the different areas, or some sample from the same area, or some sample from the different time periods, or some sample from the different administrative positions, or some samples for the different research designs, those should be normally used and normally distributed. So normally what happens, large the sample size, we will get the accurate results. Okay, but whenever the larger sample size is there, it may be more costly, it may be tedious to work, it is a time consuming. Okay, then the second thing is that there is some time limit is there, constraints are there. That is why we cannot get the larger sample size. Again, suppose I take a very small sample size, then the accuracy is gone, prediction is gone, generalization is gone, all the things are fail, the research is fail with it. So what we have to do exactly, I need the optimum sample size over here. So this is my question, that here is the population A of the 10,000 people, and I have taken the 10% of the sample, and now sample size is 1,000. Okay, and here is the another example, population B is 5,000 people, taking the 15% of the sample, and sample size is 750. Now you have to tell me that which is correct. Either A is correct or B is correct.
Ma'am, A is correct because generally we take 10% of the population. So I think A is correct.
A is correct. And anybody else? Anybody else want to say something about 5,000? Yes?
Oh, sorry. It is about less standard error and better quality. Then B will be correct, ma'am.
That's
In that
why.
case.
In case of A and B, both are incorrect. Okay. A and B both are incorrect because we don't know about the other factors of the sample size. In what situation, in what research design, on for which research question, which sampling method, which type of data the sample has taken. This we don't know about this. Therefore, generalized statement of sample size, it is unscientific in today's days. Okay, therefore no one is correct. Generally what we take in a statistics, that whenever we do the pilot study, then normally we will take a 5% of the sample. Okay, this is a general rule. Anything is not in your hand, then take a only 5% of the sample. This is a general rule, but these two examples are the very correct. So what does appropriate sample size will do for us, that it will give the appropriate statistical analysis, first of all. Second one, it will provide us the desired level of accuracy, prediction, generalization, proper reliability, and the validity of the test. Okay, that is why we need this particular sample size determination. It is a proper methodology to calculate the sample size. Suppose, how large the sample should I take? Suppose I take a sample, it is a too small. Okay, take a simple example that I went to the Solapur and I ordered the 100 chadar. Out of that 100 chadar, I got a sample in my home and I got one is defective. So I think that all are defective. So I again lot is rejected. What happened? It is a waste of time, waste of money, waste of energy, both the consumer, producer, both the waste of energy. Therefore, it may happen that one chadar is a defective, but the other 99 may be the good in one. So, whenever the sample is too small, the well conducted studies also fail to answer this research question. Or it may happen that the important effects of association may be there, but we are not conducting that particular study. This is the two things that we are going through the small sample. Now what happened? Conversely, we say that suppose our sample size is too large. The study will, it is very difficult. Again, it is a costly, it is a time constraints are there. Available cases, suppose there are no cases at all for the last sample size. Then what will happen? Again, loss of accuracy is there. So what we do? What we do is the only thing that our sample size should be the optimum, not less, not large, because that is why we are going through find out the optimum sample size. Now here are some questions I have taken. Then conducting a survey to understand the consumer preferences for a new product. Okay. Here about what exactly sample size do we need? Anybody? Conducting a survey to understand consumer preferences for a new product. How much sample size should I need? Survey study is there. So what should be the sample size? No.
Generally, we take 10% of the population for study as a sample size, but consumer preference will be very huge, ma'am, actually.
Yes, consumer preference will be huge. It depends upon the area, it depends upon the mall, then what exactly the new product is there. That should be again discussed over here. Again, the second example, testing the effectiveness of two different marketing strategies in a sales performance. Okay. Or comparing effectiveness of the two loss intervention. You can see here every research question is different, every research design is different. Okay, the sampling method is also different. You can see over here what is the prevalence of the anxiety among the adolescents. Again, the area is not given, the duration is not given, and we are going to find the prevalence of the study. Again, tracking the career progression of the employees over the period to analyze the factors. In all these cases, the research questions are different, study designs are different, effect size is different. Therefore, as per the research question, as per our objective of the data, as per our hypothesis of the data, okay, as per our type 1, type 2 error, we are going to understand what exactly the sample size. Now I am going to show you that how to calculate it. Now these are some terms that should know before calculating the sample size. I want to ask you, how many of these words is known to you? Random error, systematic error, precision, accuracy, null hypothesis, alternative hypothesis. Which one is known to you? Tell me 1, 2, 3. I know 3. I know 2. I know 3. Which one are known? The concepts are here.
Fifth and sixth,
Concepts are
null
necessary.
hypothesis and alternative hypothesis.
Okay, hypothesis you know about it. Okay, about the errors. About the errors, do you know about the
Not
errors?
much. Not
Not
much,
much.
ma'am.
Okay, what do you mean by power of test? That suppose I know the power of test, then the sample size is very accurate and it is a predictable. Therefore, do you know about power of test
No.
or effect size, design effect? It may know that the sampling methods. Do you know?
Yes,
Okay,
sampling method, research
sampling
design
methods.
also. I'm
Research
aware
design
of.
is known. Okay, so one by one, we will take a little highlight of each of this, that this all affects our sample size. Okay, this all the things affect our sample size. We'll go one by one by one. Take a simple example of the error, the random error. Okay, random error is that error which is occurred by the chance. Okay, then what do you mean by error? Take a simple example that mistake and error. Whatever we are doing the mistakes, those are corrected. But whatever the errors are there, those are not corrected. If the errors are not corrected, then there is a bias. A different types of bias is everywhere. Okay, therefore we can minimize the error or we can reduce the errors. We can reduce the errors by applying the measurements. Take a simple example of the BP. A student of the fourth year came and he take a measurement of BP. As we know that this BP is inaccurate. Okay, but second time she take again, third time she take again her teacher is taking the BP again. Then what will happen? This averaging of the BP will give you the proper BP of that particular patient. Okay, what will happen in this? Error is reduced. Whenever the increase the sample size, the repeating the experiment is there, the random error is also increasing. Therefore, what will happen? We will take a sample size as a valid sample size, or we will add some sample size in our sample size, like a 5% to 25%. Suppose my sample size is a 36 patients, then I will add the more 5 to 25% to reduce this random error because of whatever the effects of there by the reducing the averaging. Therefore, the random error is there. Sometimes what happen? The systematic error is there. The deviations are not due to the chance alone. Several factors are affecting on a systematic error. Some biological errors are there. Some measurmental errors are there. Some real errors are there. Some sampling errors are there. These all errors can be reduced or can be replaced by the taking the proper precautions and measures. That is why the systematic error is there. Second one, there is a degree that we are going to measure the several times. Take a simple example of the any emotional quotient test. Okay, suppose I prepare one questionnaire and that questionnaire is given to one person. Okay, now first time when I am giving the questionnaire to the person, he will answer me. He may be hesitating or he giving me the proper response. Okay, but the same questionnaire after some days, after some week, again I provide to the same person. What will happen? Now he knows about all the questions. Now he may be having the understanding that particular questions, and now his response is a very proper or may not be proper. This may also happen. Again, the third time the same questionnaire I'm giving to the same person, then there is a practice effect, or may there is a memory effect that he know all the things in that particular questionnaire. He may giving the wrong answers or misleading our research. This may happen. That's why what we do, the same questionnaire is given to the so many other people. Okay, 4 people I have given the same questionnaire. Okay, but the 4 people testing, retesting also giving the same responses. But I do not know what exactly the standard of this 4 people. So what should I do? I should give the another same test, like a similar test, to check the concurrent validity about my questionnaire. Now, in this case, how much sample size should I take? This is the precision of the data, but this is the precision of research methodology. That is why we can understand that these 12 people, minimum sample size should be 12. Therefore, these 12 people giving the same results to my XY test, they similar results to my YZ test. YZ test and XY test are giving the similar results. That means my responses are very correct. This I called as a precision, or this I called as a degree of the research. That is why the degree of the research is again depends upon what exactly your sample size. That's why it may happen that you are having the sample size, a proper sample size, or a valid sample size. Suppose I have taken the sample size of 120 people for the survey. But in the research journey, what will happen? I got only the responses 80 which are valid and which are giving the accurate responses over it. Then at the time of thesis or dissertation or the research article writing, what should I do? I will take 80 responses only for the statistical analysis as a valid sample size. Okay, this I called as a precision, the degree of the variable giving the accurate value for the statistical analysis. So you understand about the accuracy now. We'll go ahead. Hypothesis. Hypothesis. What type of hypothesis you have? It again affects the particular our sample size calculation. It may be one tail or two tail. Normally, we know about the hypothesis, that it is depends upon again the study designs. My study design is a descriptive, exploratory. Again, the many types of study designs are there. As per the study design, we set the hypothesis and calculate the sample size. Now, it may happen that my hypothesis may be true or the false. Hypothesis. Take a simple example that a male height is greater than the female height. This is my simple hypothesis. But whatever the data I have, or whatever the people I'm measuring the height of the people, it may happen that it may be true that male height is a greater, and it may true that the female height is a greater. It may happen because it depends upon the data. What exactly the person in front of you, it depends upon that data. Therefore, my hypothesis is true or maybe the false. So actually the reality is there, and it is a proper estimated value, and this is the actual value. The major perceived, it is the actual value. There is a difference between the estimated value and the actual value. Therefore, suppose my hypothesis is true and I am going to accept it, it is a correct value, correct decision. But when the hypothesis is true, okay, and I'm going to reject that particular hypothesis, it is again the type 1 error, which is called as a false positive results. But my hypothesis is incorrect, I'm going to reject it, then it is again the correct decision. But hypothesis is true, I'm going to accept it is again the false decision or incorrect decision. And this is the power of the test, our hypothesis. Therefore, this may happen in our research designs. So the type 1 error, which is also called as alpha, which is normally considered as a 5%. Take a very simple example. I will give you the very simple example. Every examination, it is of the 100 marks. A student got marks 80. That means he has done the 20 errors. The examination is not of the actual results. Examination is of the errors, that how much errors or mistakes he has done in his examination. That means 20 mistakes are there, that means he got 80 marks. Okay, simple thing is there. But whenever I said the 5%, 5% means out of 100 only 5 errors are there. 5 errors are there, 5 mistakes are there, that means 95 things are corrected. Therefore, a researcher is confident about the 95% data, is not confident about the 5% data, and which is an error, which is an acceptable error, which is also the margin error. And this margin error may be varies between the 5% to 25%, or normally we will take as a 5% to 15%. Therefore, normally at the ZA, or the simple error, which is also called as a level of significance, this level of significance normally we take a 5%. Why 5%? Because of the Z values of the data. We can take it also 1% when we are very, very, very confident about our data, that there is no single error. That is the 6 sigma error. The 6 sigma error as a 1% error we can consider. But normally we will take a particular 5% error. Okay. Sample size is inversely proportional to the type 1 error. Larger the sample size, reducing the errors. Lower the sample size, increasing the type 1 error. This is a very inverse proportion to each other. Larger the sample size, below the error. Again, lower the sample size, higher the error. Therefore, normally we will take a type 1 error as a 5%. Again, the type 2 error is there. It is actually the hypothesis is wrong and we are going to accept it. This is again the mistake by mistake. Therefore, this is called as a type 2 error. Normally we take a type 2 error. Now you can see over here, this diagram you can observe. The decision is that the hypothesis is true, it is correct. That means the error may be there, a small error they may be there, but it is my confidence interval. This is my confidence level. This confidence level, I will take it as a 5%. Therefore, I am very confident about 95%. Now take a type 2 error. Now my hypothesis is false and we are going to accept it. This is the type 2 error, and which is a false negative error, which is called as a beta. Therefore, the correct decision is, whatever the correct decision is, the hypothesis is false and we are going to reject it. This is called as a statistical power, the power of the test. Whenever the power of test, normally what happen, in the statistical analysis, we use the two types of test. One is a parametric test and other is a non-parametric test. But for the parametric test, this statistical power of test is always higher, and for the non-parametric test, this statistical power is a normally lower the power of the test. Therefore, whatever sample size, the simple thing is that whenever data normal means my sample size is greater than 50 or near about 50, then there is no need to check a normality. Okay, normality things, or check a reliability and validity of the data, because sample size is sufficiently large. But whenever the sample size is sufficiently large, I should use the statistical power and check a power of test properly, take a 95% confidence interval, and we are going for the sample size calculations. This is the one thing. Therefore, this power means it is a probability that test will accurately identify the significant difference or effect or the association between the samples that should one exist in the population. So, sample size is directly proportional to the power of the test. Higher the sample size, higher the power of test. Lower the sample size, lower the power of test. Therefore, normally larger sample size will give us the greater power to detect the significance, difference or effect or the association of the data. Therefore, power of test is very important factor to calculate the sample size. Now, see here is the one effect size. Here is the effect size. Effect size means what happen whenever we are measuring the different types of samples or sampling methods are there. Suppose I select the sample by simple random method. Okay. Then the sample size calculation will be different. Suppose I am taking the sampling method as a stratification. Then there are strata, there are groups. Then the sample size calculation is different. Again, I suppose I taking the cluster sampling. Then cluster sampling, again as per the cluster I need to identify my sample size. So in this way there is a some effect size. The same data, suppose I calculated by taking the sampling methods, different sampling methods, then also we can identify what exactly the design effect is there. You can see here the sampling techniques affect the sample size. See, same data is there, but the simple random sampling I will got a value 1. Systematic random sampling, I will get a value 1.2. Or stratification, I will got a value 0.8. In this way, the same data can be taken the random samples by the different methods. Then again the design, this is called, we call it a design effect. Therefore, research design, it is a very important, and this research design should be, this calculation should be between 1 to 2. Then only we can calculate for the proper sample size calculations. This is the basic things are there. Normally, for the effect size, we calculate the odds ratio. Odds ratio means it is a risk, that what is the risk with this sample size. Or we take a pilot study. Take a pilot study and consider the risk and find out the risk ratio. That is why we understand this sample is a correct or not. This is the thing. So here, the one thing is that what is the reliability, validity, and the precision. Now you can see over here. Here is the low accuracy but the high precision. The data points are together. Okay, but they are not related to the mean. They are not associated with the mean. In the second diagram, the mean is there, centrally mean is there, data points are there, but they are scattered. The random error is a large over here. Okay, in the third one, all the data points are near to the mean. Standard deviation is low, error is a low. That's why we can take this a high accuracy, high precision. The data is normal, data is a predictable. We can generalize the sample through the population. In this way, we are going through the data. Now, up to this, tell me, is there any question is there or any query is there? We are discussed about these all values. which are ready for this. What is the error? What is the systematic error? What is the reliability? Reliability, what do you mean by reliability? The same experiment can be done again and again. It will produce the same results. The repeatability of the experiments give the same results. The different sample sizes give the same results. It is a reliability. What is a validity? Means exactly the giving the same or accurate results. What exactly degree of accuracy? It is a validity of the results. Hypothesis, we know. We see about the type 1 error, type 2 error. It is necessary to understand what exactly the level of significance or what exactly margin of error we will set for our sample size calculation. Is there any question? Do you understand these concepts? Hello?
Yes, it is very clear.
Okay, thank you, sir. So we'll go for the methodologies, that how we are going to calculate the sample size. Now, procedure to calculate the sample size, there are 4 procedures that could be used calculating the sample size. First of all, the use of formula. Second one, there are ready-made tables. Those are giving directly sample size as per the level of significance and the population. Ready-made tables are available. Third one, there are nomograms. Nomograms, those are the formulas on Excel or another statistical softwares. Those will give the sample size calculations. Again, the last one, those are the computer softwares. And I will show you that the 3 or 4 computer softwares that like a EPI Info or a G Power Tools or surveysystem.com, those I show you how to calculate the sample sizes with a computer software. So we'll go one by one by one. That is the first of all use of formula. Now, whenever we are going to use the formula for the sample size calculation or the power analysis, this should based on the population study, or it depends upon the prevalence, or it may depends upon the proportion of the variable of the interest. Okay, estimated prevalence or estimated proportion of the variable of the interest I need desired level of confidence. I need. And third one, the acceptable margin of error. Margin of error means how much error the researcher is going to accept. That is a margin of error. Now, this is a particular things that whenever I'm using the formula, the confidence level that normally 95%, it is a 1.96. This value is defined value, 1.96 defined value. 95% level of significance, it is again the defined value. Now, this is the formula. N is equal to Z square PQ upon D square. Now, N is a sample size. Z is the value given to you, that is 1.96. Wherever you go, suppose you are using this particular formula, N is equal to Z square PQ upon D square or E square. In some books you will find the E square, in some books you will find the D square. P is a prevalence or proportion of the things. Q is a 1 minus P, okay, and D is a error, that the error acceptable error. Okay, simple. So here N is the desired sample size when the population is greater than 10,000. Again, Z, it is a standard normal variate. You just remember that wherever there is a Z, normally for the two-tailed test, you will take it as a 1.96. Suppose it is a one-tailed test, then we are taking it as a 2.56. But normally we take a both sides or a two-tailed test. That's why it is a 1.96. Again, P is equal to proportion of the data, particular proportion of target population. Q is equal to 1 minus P, and D is equal to degree of accuracy that we set a level 0.05. So, in a simple thing, if the proportion of target population with a certain characteristics, it is a 0.50. Proportion of particular, suppose take an example of thyroid in a particular Kolhapur district. In the review of literature, I found this prevalence as a 0.50. Therefore, my P is 0.50. Z statistics is already given to you. It is 1.96. So what I need, the degree of accuracy or the margin of level, it is a 5%. or you may vary this particular margin of error to the 5% to 15%. Okay, it may happen, but it depends upon the data of the population that you exactly got. Take a simple example that suppose I am studying about the women entrepreneurs that who are registered for the DIC. In the table or in the records, I got near about 600 women entrepreneurs in the data of the DIC. But whenever I inquire about those all 600 women entrepreneurs, then I will find that many of the women entrepreneurs are not there. Their husbands or their maybe relatives are doing that particular businesses. Then what will happen? I'm not getting my accurate population, or I'm not getting the false positive population. In that case, you may increase your margin of error. Increase the margin of error to the 10% to the 14%. Then we will get the sample size proper. In that case, it is depends upon the researcher that how exactly he will accept the margin of error. It will happen after the pilot study. Again, so here is the calculations. N is equal to z square pq upon d square. So n is equal to 1.96. This is given and this calculations gives me 384. Everybody, I want to say, remember that in a statistics, taking the sample size as a 600, 700, 900, 1500, 2000, it is a very unnecessary thing, because largest to largest population at a 5% level of significance, it may be the near about 384 or 390. You may take a 1 lakh people, you may take a 2 lakh people, you take a 1 million people, you may take a 10 million people, you may take a 20 million people, and the sample size is 384, gives you the same results that what will happen in the maybe the 10,000 or 1500 people. The same results are there. Therefore, optimum sample size matters. Optimum sample size, not go unnecessary the for the larger sample sizes. I will show you how it comes. So this is another example that I have a now comparative group of study. The two groups are there. Two groups are there, and I want to take a two subsamples. Those may be of the equal number of cases or maybe unequal number of cases. Then also I'm going to use the formula n is equal to 2z square pq upon d square. Same formula, but this particular calculation of 184, it will go to the one experimental subject and the one second comparative group also. 184 to one, 184 to other. This is very easy in a calculation of E power tools, EPI info and the G power tools. But manually also we can calculate this particular things as a comparison group of the things. N is equal to simple formula 2z square upon z square pq upon d square. Suppose I have a two groups or a three groups. Okay, simple thing. Now, there is one more method that using the ready-made tables for the sample size calculation. Now, in some cases, we are not eligible to get a particular population size, but near about or approximate population, we know about it. That's why we'll go for the ready-made tables of the sample size. Okay, for the different designs and the situations. So I will show you this particular table of sample size. Anywhere you can Google it or go for the website. Anywhere, find out just the sample size determination table. This sample size determination table will give you this particular table, that is a required sample size for 95% confidence and 99% confidence. That means here the margin of error is a 5% and here is the margin of error is a 1%. Now you can see the population size is given the left hand side. Left hand side, all the population sizes are here. 10, 20 up to 75, 100 to 300, 400 to 800, 1000 to 2500. Now here is the one value. Suppose my population size is 300. I need a sample margin of error as a 5%. Then I will got a sample size as a 169. Simple thing is that. Or maybe for 1% margin of error, I will get a 205. This is the very simplest way to find the sample size. Okay. Again, you can see I want you to observe this, that 1000 population size is there. What is the sample size? 278. 50,000, 381. 1 lakh, 383. Again 5 lakhs, 384. It is not going beyond that. Sample size is not going beyond that at the 5% level of significance. Again 1 million to 25 million, 10 million, 100 million people, 300 million people, still the sample size is same. 384. It is not 560, 600, 700, and all those things. It is not there because normally we take a 5% margin of error, and 384 it is a sufficient sample size for the calculation of the study. It's the simplest way to calculate the sample size. See here the margin of error is also, but it is not going beyond this 663. Okay. Again, depends upon either the stratification is data there, or the clusters are there, or the grouping are there, or the systematic study is there. Then again, this will vary one to one. But again, this is the normal method to calculate the sample size. Do you understand this? The simple way to calculate the sample size. Yes. Calculating the sample size. This is a random table. Now here I have taken one example that there is a particular study of the share market. So the market cap is given there, population, required sample size, sample collected 80, difference between the sample size is 0. This is a large cap, this is a mid cap, this is a small cap, and the grand total is 5101. Where I find this particular data, it is a source if a particular mutual funds India. This is a particular stock market से ये data ले लिया हमने. Okay. Now for this each category I need to calculate the sample size. For each category of this I need to calculate the sample size. So I use this particular link, and this link is about the same data that here about given this data. Okay, this is the random table. With this random table, I can calculate this one, the required sample size I have taken. Okay, the required sample size large cap as the 5%, 80 sample size I have selected with this particular link, and this is link of the same. Therefore, total 545 required sample size I have taken by the ready-made table for the this study. Why this is so? Because it is already available, all the data, all the population is available to me. Available data is there, therefore it is easy to calculate the sample size with a required sample size table. So, next one. Here we are going to use the nomogram. But for the formula method, I want to discuss you about one more example. I am stopping the sharing of this PPT. I am sharing one example with you.
Excuse me, ma'am. I have a doubt. Can I ask now?
Yeah, sure.
Ma'am, suppose if I'm studying, if my my population is vegetarian people in certain city. Now it is very difficult to find the population in the first place. Really, it is very difficult. Who is
Yeah,
vegetarian? Who is non-vegetarian? So
yeah.
sometimes we are not sure what is the population size. So in that
Yes.
case, what should be the sample size?
Then we are not sure about the population size. Then normally we will take as a large population size. It is at
Okay,
about 10,000.
about 10,000. So we assume
About
and we take.
10,000. We assume that it is about 10,000.
Okay, okay, ma'am.
Or
Yeah.
it is another way that we will go for the review of literature. That is
Okay.
there any paper, that is anybody researcher has published any
Uh-huh.
paper about this vegetarian people, vegetarian thing. This is
Okay.
another way to find the proportion of that particular thing.
Okay. Otherwise, generally we
Otherwise,
take.
you will take a more than 10,000. Simple.
Okay. Okay, ma'am. Thank you, ma'am.
Huh. So I'm going to show you the formula method again. Is it visible to all?
No, no, no.
No, ma'am.
No. One sec. Now it is visible?
Yes.
Yes, okay. Now see here. Study design and sample size calculation. Sample size, this is the another formula. This is the another formula that we can calculate the sample size. Now see here, take a previous example, the same example, that XY test is there, YZ test is there. The two tests are there. I need the comparative results of this. Comparative study is there. Comparative study is a very valid study to give the proper results or the estimated results. That's why we are using this particular formula, that n is equal to z alpha plus z beta bracket square p into 1 minus p q into 1 minus p and p minus q bracket square. Now here it is z variant, it is about the alpha error. That means this alpha error, it is about the population. Z beta, it is a constant value 0.84. This Z beta is a power of test. In the another formula, n is equal to z square pq upon d square. We are not considering the power of test. But here in this formula, z alpha plus z beta, in this formula, we are considering what exactly the power of test. And that is why we are using this as a valid formula. That is a
Both
p
are
into
valid.
1 minus p and a q into 1 minus p, and difference of these particular proportions, two comparative groups or two comparative proportions of the variable. This is another formula. This is given by the show. This particular reference is there. This formula is there. So normally what we take estimates as 80% power of test. Type 1 error is a 5%. That's
Excuse
what
me, madam.
it is. Yes, sir.
It is not visible.
It is not visible.
Yes. That written
Should
text is
should
not.
written text is not visible.
Yes.
Now,
Ah, yes, it is correct. It is not in PPT, I think. It is in text
it
only.
is not in PPT. It is just calculations. That's why I put it in a Microsoft Word.
Uh-huh.
So you can see the formula.
Ah, yes, now it is correct, visible.
Yes, n is equal to z alpha plus z beta bracket square into bracket p into 1 minus p plus q into 1 minus p divided by p minus q bracket square. Okay, now this is Z alpha, it is a particular 1.96. Okay, Z beta, it is a power of test, it is a 0.80. More than 0.80, you can take anything. More than 0.80, up to 0.95, 0.80 to 0.95. Anything you can take Z alpha plus Z beta bracket square, P into bracket 1 minus P, Q into bracket 1 minus Q. What is this P and this P? It is a P and Q are the proportions of the variables. Okay, these are the proportions because there are two comparative groups, and we'll take a difference between that particular things, P minus Q bracket square. In this way, very simple. Normally, we will take a 80% power of test, type 1 error 5%, and type 2 error 20%. That is a 80%. Okay. So substitute values are substituted over here. Then I will get a sample size as a 32. Okay. Now a minimum of 32 subjects per group completing the trial will be given to the good external validity to present the study. This formula is a more precise formula. Why it is a more precise? Because it gives us the power of test. Power of test as a 0.80%. Therefore, this is a properly precise formula. So, in the next, what we will do, I have already calculated the 32, but I am not sure that all the 32 respondents will give me the response in a total ways. Or it may happen that my patients are drop out or my consumers are not giving me valid responses. In that case, what we will do, we will consider the recruiting 5 to 25% more subjects. See over here, this is recruiting 5 to 25% more subjects. Why I need to take this more subjects? Anything will happen. Patients may drop out. Consumers may not respond. Those may be literate, illiterate, or which kind of responses they are given, they are not to be considered for the statistical analysis. In that case, that is why we have taken this 5 to 25% more subjects in our study. So, taking into consideration, I have taken the 10% of this n. This 10% of n divided by 1 minus 0.1. Now it is a 35.55. Now 35 on 55, we cannot apply directly because it is a fraction value. Sample size, it is an integer value. That's why I rounded it and we have given the approximately 36 subjects per group should be recruited for the trial. In this way, we are calculating the sample size in the two ways, either in a simple way or take this particular formula for the calculation, and this is a very appropriate formula to calculate the sample size. Is any doubt is there? Here is again, I have explained you that what type of statistical analysis should be going to for this 36 subjects. So I am keeping this below. Now, we'll see that the sample size calculations for the different types of study designs. Is it visible now? Should I raise the? Is it visible now?
No,
No. Yes, sir, now?
partially, partly visible, not all.
Not all visible.
PPT will be better if you can test what for what test.
Okay, tomorrow the same example we will take a tomorrow. I will put it these examples in a PPT tomorrow. Okay,
Yes,
we'll go for the next session. Okay, this will be not visible, so we will go next. So this example of the ready-made tables, do you understand all? Example of this is a table of ready-made example. That is a ready-made table is available, and with the ready-made table we go for the sample size determination. Now the next. It is a monogram. Monogram means what? What is a monogram? In the Excel or the things, the simple things are already calculated, and we will got a tables of it. These tables can calculate the sample size for us. This is called as a monogram, but normally we are not using the monogram because it needs sometimes the statistical formula, calculated formulas are there. And these formulas, suppose we don't know about the formula, then we cannot go for the monogram. But we can use the to calculate the effect size or to calculate the research design or to calculation of the nomogram. And after this using the nomogram, I am going for the sample size calculation. Therefore, nomograms is one of the way to calculate the sample size. Now, these are some of the methods that computer softwares for the sample size calculation and the power analysis. Now, see, you can see over here, these are the many things. EPI info, NQuery, power and precision, sample, Stata. This is one of the software. Again, SPSS is the software. G Power Tools is a software. And Survey System, it is a software. These are many softwares that we are going to learn today and tomorrow. EPI info, we are learning. G Power Tools, we are learning. And surveysystem.com, we are learning. Okay. So, determining the sample size that, so I will share this. We'll go for the surveysystem.com. You can do this with simultaneously with me also. That open the website surveysystem.com. Open the website surveysystem.com. Surveysystem.com. You can open this on your mobile also, or you can open on a laptop or a network also. In this surveysystem.com, there is a simple thing. It is a sample size calculator. Now you will see that this one is a particular site. You will get Creative Research Systems surveysystem.com. Now, here is they have given you already the sample size calculator. With this sample size calculator, easily we can find the sample size and which is a very valid with a your proper effort. So we will go over here. Now, the screen is visible to all. Screen is visible to all.
Yeah.
Yes, ma'am.
Now, see here. Now, third, three things are given over here. You can see here. Confidence level. Again, we already see that what is confidence level. Confidence level, it is a 95%, means it is a level of significance. It is already given to you. That means we are accepting the margin of error as a 5%. This is clear, very clear. Now, the population. Now, how to calculate this particular population? It depends upon two or three things. That first of all, I will take a population from review of literature, the one thing. Second thing, you can find the population with the nearby systems. Okay, I will show you the another example of it. That suppose I want to study about the um, particular administrative staff is there and how the students are reacting for the administrative staff. Okay, those are not teachers, but those are in a college and how they are helping the students. This is my research. Then I need to find out all the engineering colleges and how much administrative staff is there. Therefore, in a easy way, we can find out the population over there. Or the second thing is that suppose a particular typhoid study is there, or maybe thyroid study is there, then in the last 3 years in my college or in any hospital, how many patients are visited of the thyroid? This is my population. In this way, you can find out the population of your study. The simple thing is that if you don't know about the population, that I don't know that, and this is a very normal thing, general thing, then I need to find the population. Then take a 10,000 over here, take a more than 10,000. But if you know about the population, then put the population value over there. Next thing is that the confidence interval is there. Confidence interval means for which interval you are going to study this. Confidence interval, everybody know that mean plus or minus sigma. Normally we will take a confidence interval from the 3 to the 15. 3 to the 15. Why 3? Because normally confidence interval has a value mean plus or minus 3 sigma. Mean plus or minus 3 sigma. If it is a standard normal variate, then mean is 0, standard deviation is 1, therefore the value comes 3. Therefore, confidence interval we normally take it as a 3 to 15. Therefore, suppose my population is a 100. We'll start with 100. This is my population. And my confidence interval, I have taken 3. Now, what I have to do? Just I have to go for the calculation. Then the sample size I needed is a 92. Okay. But my population and the sample size, those are near about. Here I am using the census sampling method. Census sampling method. That whole of my data will cover over here and I will get the accurate results. But this is very difficult to go for the 92 sample size. So what should I do? I should raise my confidence interval. I raised my confidence interval. Now my calculations are 49. Okay, this is may possible to go for the possible. I'll take a 15 as the confidence interval and I will got a sample size as 30. Now this 30, it is a large sample size. See over here, large sample size. Any sample size less than 30 is considered as a small sample size. Any sample size greater than 30 is considered as a large sample size. Whenever I have a large sample size, the data tends to normality. Any of the distribution is there. Okay, any of the distribution is there. Maybe Poisson, maybe normal, maybe hypergeometric, maybe geometric, or maybe binomial. Any distribution which will tend to the normal distribution if I got a sample size 30. That means minimum sample size to go for the normality, it is a 30. That is why. Suppose I have a, then what is the minimum sample size should I take? Suppose the sample size is less than 30, then at least I should take a sample size as a minimum sample size as a 12, in normal cases. Okay, but for that less than 30 sample size, I need to check for the reliability and validity of the data and normality of the data. That is why normally we will take a sample size larger than 30. That is why suppose there is a normality check also, then we are not lagging with the accurate results. That's why we have taken here the sample size 30. But suppose in the term of the course, just I will calculate the sample size 30. If we are, is these results are valid, or is this sample size calculation is accepted by the guide, or is this sample size calculation is accepted by the universities also? Yes, it is accepted. Okay, you calculate it, take a screenshot of it, give the proper uh, wherever you find the population, give the proper reference of it, and it is a valid. Now, suppose I'm a researcher and my guide says that you need to take a list of the population of the 60 people. Okay, then I know my population size, it is near about 500. Then I will calculate the confidence interval. So my confidence interval is 11.88. I got the confidence interval. Then in case, as per the requirement of our guide or as per the requirement of our research, suppose I need that this particular 60 as a sample size, then in that case, you can calculate the confidence interval and put this confidence interval the same over here as a 500 population size, and my confidence interval is 11.88 or a 12, then I will got a particular near about 60 sample size in my calculations. This is again the very simplest method to calculate the sample size. It is not need to go for the statistician. Ready-made tables are there, simple formulas are there, or this is the one of the way that you can calculate the sample size over here. Simple surveysystem.com. Another things are there, surveymonkey.com is also there. There also you can calculate the sample size. Is there any question for this one? The very simple thing you can do also with your computer or the calculators. Is there any question?
Can you explain the confidence interval once again? I'm not very clear on that.
Confidence interval. Okay. See over here. Sir, I will give you one simple example that you will understand the confidence interval. Okay. Take a simple example of the milk pouch, 1 liter milk pouch. Okay. Everybody know that in that particular 1 liter milk pouch, there is always a 1000 milliliter milk is there. There should be, because 1 liter is equal to 1000 milliliter. Okay. Everybody, you and me, we are working with the 12th science and we are doing the experiments in the schools and colleges. That in a particular that PPT, putting the one drop of 1 milliliter, it is very difficult. It is very difficult to put the 1 liter milli drop of 1 milli, 1 or 2 millimeter milliliter. It is very difficult to put that particular milliliter in that tube. So it is not at all possible that the 1 liter milk pouch having that particular exact accurate quantity of 1000 milliliter. Not at all possible. And to spread this milk to the millions of the people in India. Not at all possible. Okay, it may be machine, it may be manual, it may be whatever the systems may be there, but it is not at all possible that every milk pouch of the 1 liter having the milk of the 1000 milliliter. Not possible. So what we will accept, that the milk pouch may be having the 995 ml or maybe 1005 ml or maybe the 900 ml to the 1010 ml. This is acceptable. Every day we are accepting that particular milk pouch, and still we are agree that the things is there. Therefore, if the large milk is there, it is a producer's risk. If it is a less milk is there, it is a consumer's risk. Risk is there. Therefore, whatever what we do, we took a golden mean point. that there is no risk to the both the people, maybe the consumer, maybe the producer. So we'll take a mean value of it. We'll take a 995 ml to the 1005 ml, and whatever the volume quantity of the in between this may be accepted to the both. What is the confidence interval? Now, my mean value it is a 1000 ml, but I accepted 1005. I accepted 995 also. Then this particular interval is called confidence interval. And everywhere you go, there is a variability in the data. Variability in the data. So, I know the variability of the data. But at a certain level, I need to accept that particular variation. And whatever the variation is there, but accept as the minimum margin. To accept as a consistent level, accept the things at the minimum bias. That is why we put the confidence interval. So it is just a range between the mean plus standard deviation and mean minus standard deviation. Okay, and normally what happens in this mean plus 3 standard deviation and mean minus 3 standard deviation, the whole the data is covered. All the data in the world is covered. That's why we normally put the confidence interval. So whenever we put this confidence interval, then there is a margin that we are accepting that margin. We are accepting that margin. Suppose with this, take a simple example that I will got a odds ratio with this sample size 1.34. 1.34 that a woman, they are accepting they are taking the high caffeine or having the daily high coffee, that leads to the breast cancer. This is a simple example. But whenever I put this particular 1.34 as an odds ratio, there is a 34% risk is there. That risk of the 34% is my confidence interval. That the women, I'm 34% confident about that. The women who are accepting the caffeine or taking the coffee every day, they are leading to the breast cancer. This is a simple thing. That's why we are using this confidence interval, that we cannot go for the point estimation. It is the exact mean value, we cannot go it. That's why what we do, we'll make it as a confidence. Okay. The simple thing is that for we are preparing the confidence interval. This is we call as a confidence interval. Yes, sir?
Yeah, ma'am, is it expressed in percentage like confidence level?
Three things are different, sir. Three things are different. Confidence level is different, confidence interval is different, and confidence limits are different. Now see over here. Confidence level is different. Level means we are going to accept the error to the 5% level. Okay, level. Level means past. Okay, suppose my sample size is 30. Then out of this 30, 5% data may be false or maybe not giving me proper responses. This is my confidence level. Okay, confidence level means we are going through the hypothesis level. That my hypothesis says that, but 95% above I'm confident about my data. This sample says maybe 30, maybe 500, maybe 384, maybe 200. Whatever the sample size is there. This is my sample size of the 200, and this is this data of the 200. It is for my 100% data. In that 100% data, the 5% may be lagging or 5% may be giving false positive results. This is I call as a confidence interval. Confidence level. This is a level. Okay. Then what is the interval? Interval means we are accepting mean values and spread about the mean values to the confidence of the mean plus or minus sigma level. That means we are setting a confidence interval that I should not get the outliers. I should not get the outliers. That the outliers should spoil your data. Total data will be spoiled with it. So we set a cover confidence interval that I will accept this value between this and this. Beyond this value, I will not accept. Those are outliers for my data. That is why confidence interval is there. And whatever the limits are there, confidence limits are there. What is my minimum value of confidence interval? It is my confidence limit. And what is the maximum value of confidence interval? It is my maximum limit. Or therefore confidence lower limit confidence upper limit is there. Therefore, three things are different over here. Level is different, interval is different, and the limits are different. But the confidence is there. Whatever we are saying, not at the limit estimation, but the interval estimation. Yes, sir.
Okay, ma'am. Ma'am, just one more doubt. How do you come to the interval? Say, for an example, I have a data. I have a population of the. Imagine I'm trying to study a group of farmers. That the total population comes to say 5 lakhs. How do you come to that level? How do you determine the confidence level in this case?
So for that, I need to have some pilot study with me.
Okay.
The pilot study with me, or maybe the some variables, some of the parameters of you. And some farmers are there, and you are selecting your dependent, independent variables, okay, or the parameters. On those level of parameters, I will take a pilot study, or take a simple example of the ages. Okay, these farmers are there. Age is my one of the parameter. Then I will take a pilot study, ask to the 10-15 people at what age of the farmers that we are applying this particular data. Then we consider this confidence interval on the basis of one of the parameter. One of the parameter, one of the variable of it. Then we'll take a proper mean, a standard deviation of particular ages of our pilot study, and we decide the confidence interval. And this may be my confidence interval for my study. Or normally we can take it as a 3 to 15. It is a normal levels, but we should go for the precise study, then we'll go with. So this formula, what I say, this formula we are using for the general studies, very general studies. Here you can see I am not studying about power of test. Okay, we have not seen the research design. We have not seen the sample design. We have not seen the sampling method. Nothing is there. This is a general formula. That some things are there. Some, suppose I want to go for the deep minute study, I will go for the another methods. But this is a common method. Level of the UG, this will go. Level of the PG, this sample size calculation will go. But for the PhD level, I will not suggest you to use this survey system. But this is one of the method. Whatever the methods are there, I am going to teach you all the methods that calculating the sample sizes.
Okay, ma'am. Thank you.
Okay. Yes, now everybody clear with this?
Hello, ma'am. Can I ask one question?
Yes.
Ma'am, for comparative group, you are giving another method that you are using 2Z for calculation of comparative sample size of comparative groups. But we are using that one first method that n is equals to z square pq upon e square or d square that. And when we are getting that sample size, we are using same sample size for the other comparative group. Ma'am, is it wrong?
Yes, it is wrong.
Then
it is a simple thing that on the base of prevalence you are calculated the n. Okay, but the same n you are applying for the two things comparative. Okay, and you have a comparative group of study, then two groups are there. Those may be trial group, control group. Is it there? Yes or no? Yes. Maybe one of the experimental group and one is the standard group is there. Then after that you have to prove the significance for the before after in a trial group. Again for the significance for the standard group or a control group. Okay. And there is a t-test. T-test for the trial group. T-test for the standard group or a control group. Okay. Again you need to compare about the which is the better, experimental is better or the trial is control is better. Okay.
no, suppose ma'am, if I'm
That is
getting
why this suppose it may happen that if the control group is already proven group, there is no need to take a samples. There is no need to take a samples. The minimum sample you can take for the control group and take a proper calculation for the experimental group.
Okay, but ma'am, in my study, I calculated the first by first method that you are giving that n is equals to z square and all
Yes,
that.
like with your place.
Means,
Yes.
suppose I got 100 number of patients, that my sample size. Okay, then I'm taking 100 patients for my group A and another 100 patient for my group B. Then it is wrong, ma'am.
Because your method of calculation is wrong for the comparative group. Your
Okay.
study design is different. Your study design is different. As per the study design, you need to choose your formula.
Okay. Okay.
Huh.
Thank you, ma'am.
That is what I was showing you, but it is not visible. So I put that all the things on the PPT. Tomorrow, at the start of the lecture, I will show you that how to calculate the sample size as per the research design. Different research design and as per the different sampling methods also. That is, a stratification is there, systematic sample is there, cluster is there. So I will show you that part.
Okay, ma'am. Thank you.
Huh. Yes. So are you clear with this all?
Yes, yes, yes.
Yes. So shall we go for the next method?
Yes.
Yes. So here is one more screen which is called as a open API. Now you can see on my screen that I have put over here open API. Open API. Actually API info, it is a proper software. Proper software is there. But for the web purpose, we can use the open API info. See, open API. It is a free web-based open source operating system. It is a software. So we can use this particular open API info website for calculation of all the things, also for the testing of hypothesis, also to calculate the descriptive statistics also. Okay. Therefore, for the whatever the data is there, commerce, management, social sciences, maybe medicines, we can use this particular open API software. Open API menu. We'll open API menu. Now see here at the left hand side, is it visible, sir? I think this is low. Now you can see now. It may possible that you can see now. You can see now. This is open API, open source epidemic statistics for the public. This is a particular website. So in the left side, this at the left hand side, there is a sample size. So there are four methods to calculate the sample size. One is proportion. I know the proportion of my variables. Second one, it is unmatched CC. The third one, it is a cohort RCT. That means suppose we have a comparative group of study, then we are using this cohort RCT. And the last one, it is a mean difference. Mean difference means suppose I have a pilot testing. Then I got my results with the pilot test. Then I can calculate the sample size with the help of pilot test, which is more accurate. Next one, here in the same software, we can calculate the power of test. Okay, this is my sample size, and these are my results of mean and standard deviation. Either I am correct or not. This is a power of test. Okay, so we'll calculate the sample size here one by one. So I will go for the prevalence first of all. That is a proportion of study. Here you can see the table is appeared over here. I can put here the enter new data. Is it visible to all? This table is visible to all. Sample size for the percentage of
Yes, ma'am, it is.
Yes, ma'am, it is visible.
Simple, very simple. Sample size calculation for the frequency in a population in a random sample. Again, I have to put the population size here. Take a number 1000. Okay. If large, leave as 1 million. Or if large population is there, put it as a 10,000 directly. Okay. Now, what exactly my anticipated proportion or anticipated frequency in the population? Suppose I have taken one of the simple example that the number of people having the thyroid disease, it may be the 14%. Or this is the 14%. I have taken this particular thing. I don't need to set the confidence limits. I already explained you what is the confidence limits. Okay. Design effect, it is a 1 for the random sample. Then after this, putting the population size and anticipated frequency or the proportion of the frequency, I will go for the calculations. And you can find out over here. At the 95 level of percentage, I got the sample size of 157. Or the 80% confidence interval, I got the 74 sample size. Is it? Yes? Yes. The same formula, what I told you already, that the Z alpha minus Z beta into bracket P into 1 minus P. The same formula is used, but in the software. And is equal to. Therefore, whenever I got this sample size, what I do, I will just copy paste it. Just copy paste. Normally, copy paste, put the formula also with it, and copy and paste to the Microsoft Word file. And whatever the samples is, it is decided over here. Just give below this, give this URL as a reference. And this is a valid sample size that you got over here. Okay. This is the one of the method to calculate the sample size. Again, I will show you. Proportion. Enter the new data. Just enter the data over here. Suppose my population is now about 10,000. That is a 10,000. 10,000. My anticipated frequency of the proportion of data. Normally, we see that 10% people using the sweaters every day. This is my calculations. Then I will go to 137 sample size over here at a 95% confidence interval. This is a scientific method. They are calculated this formula with this particular formula. So this is one of the method when I know the proportion of my variable. Now, here is the one method which is a cohort or RCT. Now, you can see over here, whenever you have a cross-control study or cross-sectional study or the cohort study particularly, then we can use this particular EPI info method. That is now you can see here, the two-sided confidence level, it is already given here. 5% confidence level already given here. Beta power of test is already given here. Now, ratio to the unexposed to the exposed sample, it is given already 1. That means in the two groups, we are having the equal size of the sample. Two groups equal size of the sample. Now, percentage of unexposed with outcome. It is what is my prevalence of the study or proportion of the data. Suppose it is a 15%. Then I will go above and calculate the sample size. Okay, exposed. Now you can see that because I have taken already the sample population size as a more than 10,000. Therefore, my sample size comes to the 1985. This is a more than 10,000. This is one of the method that we are using this in the data. Or we can take this particular mean difference. Enter the new data. You can see here already the 95% is decided. Power of test is 80. Sample size 1 of 1 to 1. The same mean is given for the two groups. This is a pilot study. and standard deviation is given for the pilot study. So we are using the calculations, and I got the sample size for one group 152, sample size for the group 2 it is again 152. This again method we can use for the sample size calculations. Yes, this is about the EPI info. This is EPI info table. You can calculate the power of test also, cohort and the proportions. Hello?
Yes. Hello.
Yes. Any doubt is there?
Use this CPI info method for dissertation for our thesis as well?
Yes, sir. This one. It is those all software methods are very valid. Just you have to give the reference of it. Dissertation.
Okay, ma'am. Thank you,
I'm
ma'am.
a statistician, and near about more than 200 theses I have done for the statistical analysis. And many researchers came to me to calculate the sample size also. So suppose what happened many times, what happens, they already did the data, and I have to put for previously retrospective sample size calculation. Still also it is valid, and we are doing it.
Okay, ma'am. Thank you, ma'am.
Yes. Any other doubt?
Ma'am, can you please
Hello.
share your email ID?
Yes, why not? Sure. I'll share you.
Okay, ma'am. Thank you, ma'am.
Just a minute. It is in a PPT. I will just share you. One minute. So the again we are here at the slide. We are here. How large the sample do I need? Okay, but it depends upon again our budget. Budget. What is my budget? What is time available? What is my executive decisions are there? Administrative methods are very important in the research design. And what is the statistical methods? And what is historical data or a review of literature? What it says? Again, we find. So these are some of my books that I have written. The books uh, of the statistics. Those are about the all research methodology as well as the statistics books are there. This is one of the book as a statistical inference. Those are useful for the whole postgraduates and the researchers also. Okay, PhD researchers and the faculties also. This is one of the thing that statistical glassography of the woman entrepreneurs. Again, these books are the test books. These all are the test books to the university. So this is my contact number. If anybody needs it, this is my website dranjaliupadhyay.com, dranjaliupadhyay.com, and is my phone number. I think this is today's session.